Hello everyone, welcome back to ng.classes. I hope you all like my previous video, and if it helped you, please do subscribe my channel. And yes, if you want me to discuss any other topic, please comment in the comment box. So today we are going to discuss lines and angles. Here we will discuss some basic definitions at first, and after that we will discuss some theorems related to lines and triangles. Now let's see what's the difference between line segment and rays. So at first, let's focus on line. We can draw a line like this. Here we can see two arrows are there at two end points, which represent this line can be stretched indefinitely in both the direction. Let's see how. Like this. And like this. That means whenever we have to draw a line, we can draw it like any length, like this, or like this, or maybe like this. As we can see here, the line has no end point or there is no stop point. It is extending continuously from both the direction. Because of that, we cannot measure the length of this line. Let's say it's line L. We can represent it with any letter, or we can also say it's line AB. We can write it as line AB, or we can also say it's line BA. There is one more way to represent it, that is line AB. On the head of AB, we will draw the symbol of the line, like this, or BA, like this. Now let's see what's line segment. So line segment, as the name suggests, it's a segment of line. Segment means a part of the line. We can draw line segment like this. Let's say it's a line segment AB. We can write it as AB, line segment sign, or we can also say it's line segment BA. Here we can see we have two end points. That means end point A and end point B. We can also measure the length of this line segment. Let's measure it. As we can see here, it's of 14 centimeter. So this is the line segment which is of length 14 centimeter. We can also create different types of polygons with the help of this line segment only, where we can measure the length of each side with the help of ruler. Now let's see what's ray. As we know, in real life, ray means a ray of light. Here we are talking about the same ray. Can you see the ray? Here we are having one starting point, which is also known as end point. Why it's called end point? Because here we are having a fixed point, and it is going indefinitely in other direction. Like line, we cannot measure the length of this ray, and we can represent this ray as ray AB, which can be written as AB. On the head, ray sign. Please be careful, we cannot write it as ray BA, because we have to represent the sequence carefully. Here the first letter represents the starting point, or also known as end point, and the other letter represent the direction in which it is going continuously. Now let's see what's the difference between collinear points and non-collinear points. So collinear, here the name says all about itself. That means co means together, or common, or join. So points which exist together on same straight line are known as collinear point. Let's take an example. Suppose we are having a line segment AB. Here, if we are having a point M, point N, like this, then we can say all the points, that is A, M, N, and B, are sitting on same straight line. Hence, these points are collinear points. Now, what's non-collinear point? The points which are not lying on the same straight line are known as non-collinear point. Let's take an example. Here, as we can see, point M, point N and point O are non-collinear point because it's not lying on the same straight line. And also point P and point Q are non-collinear point. If we have to mention collinear point from the second figure, so collinear point, that means point on the same straight line, will be M and P, P and N, similarly N and Q with O. Alright, these are the sets of collinear point. Now let's see some different types of angles. So here at first we are having acute angle. Now what's acute angle? Angle which is greater than 0 degree and less than 90 degree. If we are having this angle as x, so the value of x will be greater than 0 and less than 90. Here the value of x can be 10, 20, 15, 30, 40, anything. It has to be greater than 0 and less than 90. Such angles are called acute angle. Now the next one is right angle. That is of 90 degree. Whenever we are having a 90 degree angle, it is also known as right angle. So, right angle. Let's move to the next one. So, the third one is known as obtuse angle. Here, if we are having this angle as a y, then the value of y must be greater than 90 degree and less than 180 degree. Be careful, if it's 90 degree, then it's called right angle. And if it is more than 90 degree, that means 91, 92, 93, 100, then it's called obtuse angle. Obtuse angle. After that, we are having straight line angle, which is of 180 degree. So, this total is 180 degree. And that's called a straight line angle because whenever we will draw 180 degree, we will find that we got a straight line. That's why 180 degree is called a straight line angle or a straight angle. Now the next one is reflex angle. If we are having this total angle as Z, then this value of Z must be greater than 180 degree. And it will be less than 360 degree. And the name of this angle is reflex angle. Suppose here we are having 60 degree. Then the other angle will be, as we know, one complete revolution means 360 degree. Then other angle will be 360 minus 60. That means 300 degree. Here the value of Z, for example, we got 300 degree, which is a reflex angle, right? Now let's see what's the difference between complementary angle and supplementary angle. So if we are having angles like this, where this angle represents x, where the value of x is 60 degree, and here we are having angle y, and the value of y is 30 degree. And when we will add x and y, we will get 60 plus 30. That means 90 degree. So when the sum of two angles are 90 degree, then such angles are known as complementary angle. Whereas if the sum of two angles is 180 degree, like this, then the pair of angles are known as supplementary angles. Now let's see adjacent angle, linear pair of angle and vertically opposite angle one by one. So let's start with adjacent angle. So if two angles are very next to each other, such angles are known as adjacent angle. So if we are having two angles like angle ABD let's say it's X, and angle DBC, let's say it's Y. Then angle X and angle Y are adjacent angle. These two angles are very next to each other. We can also check whether two angles are adjacent or not by checking some conditions. So the conditions are, the first condition is there must be a common vertex. That means here we are talking about angle ABD and angle DBC. We can see clearly in between these two angles there is a common vertex or a common corner point, that is B. The second condition is there must be a common arm as well. Now here we can see in between these two angles BD acts like a common arm. Ray BD is a common arm over here. And the third condition says the non-common arms, that means here if we will focus on this two angle, the non-common arms are arm AB is not common with arm BC, right? These two must lie on two different sides of common arm. So if we are having common arm as a BD, see carefully, the non-common arm, that means AB is on the left side and the other non-common BC is on the right side of the common arm. Now let's see the next concept. Here the next concept is linear pair of angle. So when two angles are adjacent to each other and also the sum of two angles are 180 degree, then such angles are known as linear pair of angle. Here we can see angle ACD is adjacent with angle DCB. Here we are having a common vertex, that is C, and also we are having a common arm, that is ray CD, and we can see here that two non-common arms are lying on the two different sides of the common arm, right? Here we can also see that sum of this, both the angle, that is angle ACD and angle DCB, will be 180 degree. So we can also say if the non-common arms are making a straight line, then we will get a linear pair of angle. Alright, let's move to the last one. Here the next concept is vertically opposite angle. So when two lines are intersecting each other, let's say line AB is intersecting line CD, then we will get two pairs of vertically opposite angle here. So here angle AOC, let's say it's angle 1, and angle DOB, let's say it's angle 2, will be equals to each other and both are vertically opposite angle. So similarly, angle AOD, that means this angle, will be equals to angle BOC and both are known as vertically opposite angle. Now let's see some concepts at first, and on the basis of this concept we will discuss some axioms. So the first concept is intersecting and non-intersecting line. So if we are having two straight line, let's say straight line AB and a straight line PQ, then both the straight line will be either parallel to each other or will intersect each other. So it can be either parallel like this or it can intersect each other. Now your question will be, what if we are having two in such a way that neither it's parallel to each other nor it's intersecting each other? So let me show you that case. So if you are talking about this type of line, let's say line PQ and line MN, then when you will stretch the line, when you will expand the line, let's extend it. Can you see eventually it is intersecting each other? So there can be only and only two cases when we are having two straight lines. Either both the line will intersect each other or both the line will be parallel to each other. All right, let's move to the next concept. So the next concept is pair of angles. We have gone through the concept of complementary angle, supplementary angle, linear pair of angle, adjacent angle. So suppose we are having one straight line like this. Let's say it's MN. And on this straight line MN, we are having a ray. So let's say we are having a ray OT. All right. So here, how many angles we are getting? So the first angle is, like, one of the angle is angle MOT, right? Let's write it. Angle MOT is one of the angle. Now another angle we are getting from here is angle TON, right? So angle TON. Now one more angle we are getting here. Can you see it? Yes, I am talking about the complete angle. That means this total angle, the purple one. So the name of this angle is angle MON, right? Now here this two angle, that is angle MOT and angle TON is making 180 degree, right? Because both are adjacent angle and also both are making a straight line, right? It's a linear pair of angle. And we can also say that sum of the angle MOT plus angle TON will be equals to the complete angle, that means angle MON, right? Now let's see the axioms. So here our first axiom say if a ray stands on a line, so if there is a ray is standing on a line, anyway it's just standing on a line. Let's see, we are having a line AB and on this line there is a ray. We can draw the ray anyway. Let's draw the ray. So if there is a ray PQ, then the sum of two adjacent angles so formed. So here we can see two adjacent angle are, let's say this is angle X and this is angle Y. So the sum of two adjacent angles so formed will be 180 degree. So the addition between X and Y has to be 180 degree. When a ray is standing on a straight line, then only the sum of adjacent angle will be 180 degree. This is one of the axiom. All right, let's move to the next axiom, and the next axiom is also another version of the same axiom. So the next axiom says if the sum of two adjacent angle is 180 degree, let's draw two adjacent angle. Can you see two adjacent angle here? It says the sum is 180 degree. That's why we are bound to draw it like this. The sum between M and N has to be 180 degree. Then only we can proceed for this axiom. So if the sum of two adjacent angle is 180 degree, then and only then the non-common arm. What are the non-common arms here? So as we can see here, SU and UT are non-common arm, where U is the common vertex. So then the non-common arm, that means SU and UT will form a line. It will form a straight line. When the sum of the angle is 180 degree, then the non-common arm will form a straight line. These two axioms together are known as linear pair axioms because both are related to a straight line, that means linear pair angle. Now let's prove the given theorem by using the previous axioms. So here the theorem says if the two lines intersect each other, then the vertically opposite angles are equal. We know that vertically opposite angles are equal when two lines are intersecting each other. Here we have to prove it. So let's prove it. So two lines are there which are intersecting each other. Let's say the name of the lines are PQ and RS. Both are intersecting each other at point O. Now let's say this angle is X, this one is Y, this one is Z, and this one is T. Here we have to prove that Y is equals to T and X is equals to Z. Now let's see straight line RS or SR. Here we are having a straight line SR and a ray OP is standing on it. So I am talking about the purple part. Now can we say the sum of X and Y will be 180 degree just by the previous axiom? Let's write it. Therefore, X plus Y is equals to 180 degree, right? Similarly, we can also say that a ray OR stands on a line PQ, right? Let's write it. Hence, the sum between angle Y and Z will be 180 degree, right? So, Y plus Z is equals to 180 degree. We have to write it in bracket from previous axiom. We have to write the previous axiom in detail over here. Let's say the previous relation was relation 1 or equation 1 and now we are having equation 2. Now as we can see both the equation addition between both the angle is 180 degree. So can we compare equation 1 and equation 2? Because we are having 180 degree in both the cases, right? So we can write from 1 and 2 x plus y is equals to y plus z. And from here we can see y and y when we will keep on one side will cancel out each other and we will get x is equals to z. That's what we wanted, right? Angle x is equals to angle z and both are vertically opposite angle. Similarly, we can also prove angle y is equals to angle t and hence we are done. We have proved it. Now let's solve some questions from exercise. So here our first question, it says in a given figure line xy and mn intersect at O. As we can see in the figure, if angle POY is equals to 90 degree and A is to B, the ratio between A and B, both the angles are 2:3, then we have to find angle C. Alright, so here this angle is given as 90 degree. So here at first can we say ray OP stands on line XY and hence the sum of angle that is XOP plus angle POY will be 180 degree. We can write the axiom over here or we can also write both are linear pair. So angle XOP plus 90 degree is equals to 180 degree and from here we got angle XOP is equals to 90 degree. That means the sum of A and B will be 90 degree, right? Here we are having the ratio of A and B, that is A is to B is equals to 2:3 and whenever we have to separate any ratio, we can only do that by multiplying the same term or the same variable with each and every part. So here let's assume A is equals to twice x and B is equals to thrice x. All right. Now the sum of A and B has to be 90 degree as we have got already. So which implies twice x plus thrice x is equals to 90 degree, which will give the value of x as 18 degree. From here we will get A's and B's part. So A, that is twice x, will be 36 degree, and B, that is thrice x, when we will multiply 3 with 18, that will be 54 degree. So we got A as 36 degree and B as 54 degree. Now we have to find angle C. Again, can we say here OX works as a ray on the straight line MN? That means the sum of angle B and angle C will be 180 degree. So let's do that. We already know the value of B is 54 degree. From here we will get the value of C as 126 degree, and hence we found C. Now let's do one more question. So here our question says, in the given figure, if x plus y is equals to w plus z, then prove that AOB is a straight line or it's a line. Okay, so we have given that x plus y is equals to angle w plus z, and we have to prove AOB is a line. Or in another word, we can say we have to prove that the sum of angle x and angle y, as you can see in the figure, will be 180 degree. Then only we can say it's a straight line, right? Or it's a line. We can also prove x plus y is equals to 180 degree. All right. So let's start the discussion. So here at first, can we say the sum of x plus y plus w plus z is equals to 360 degree? Because both are making a one complete revolution, and we know one complete revolution means 360 degree. So together they will make 360 degree, right? So according to question, we can say that. All right. Now it's already given that x plus y is equals to w plus z. So can we write x plus y at the place of w plus z? So let's write it, x plus y in equation 1, keeping it as it is, and then at the place of this w plus z, we are substituting x plus y, because both are same, is equals to 360 degree. From here we will get twice x plus twice y is equals to 360 degree. When we will take out 2 as a common factor and we will shift it to other side, we will get x plus y is equals to 180 degree, right? And that's what we wanted to prove. Either x plus y is equals to 180 degree or w plus z is equals to 180 degree. That will only show that these two are making linear pair, and hence AOB is a straight line. So it's making linear pair, or we can also write the axiom which we have already discussed, and from there we can write hence AOB is a line. Now let's see a few more concepts. So whenever two or more lines, let's say line M and line N, are getting intersected by another line, just like this. Let's say it's line L, then here L is called transversal. And when L is intersecting both the line, then we are getting few angles. Let's name it. Let's say this one is angle 1, this one is angle 2, Here we are having angle 3 and here we are having angle 4. Now here we are having angle 5, angle 6, angle 7 and angle 8. Here angle 1, 2, 8 and 7 are called exterior angle. Exterior means outside. As we can see, these angles are sitting outside or on the exterior part of the lines. Whereas angle 3, 4, 6 and 5 are known as interior angle because they are lying in the interior part or inside part of the lines. Now, as we know, alternate angles are like one on the left side of the transversal and another on the right side of transversal. So here we are going to collect alternate exterior angle. So exterior angle which are alternate with each other. So here exterior angles are 1, 2, 8 and 7. But we have to collect the alternate exterior. So angle 1 is alternate with angle 7 and both are lying in the exterior part of the lines, right? So angle 1 and angle 7. Similarly, angle 2 and angle 8 are also a pair of alternate exterior angle. Now let's see the next one. Here the next one is interior angle on the same side of transversal. So we have to focus on interior angle, but on the same side of the transversal. We know angle 3, angle 4, angle 6 and angle 5. These all are interior angle. We have to collect interior angle on the same side of the transversal. So here angle 3 is interior angle with angle 6 and both are on the same side of the transversal, right? Both are on the right hand side. So angle 3 and angle 6. Similarly, angle 4 and angle 5. These are making interior angle on the same side of the transversal. Now let's see corresponding angle. Now corresponding angle means the angles which are at same place. So when we will focus on the line M, here we can see angle 1 is on the upper part of the line M, and similarly when we will focus on line N, we can see here angle 5 is also at the same place on the same side of the transversal and at the same upper part of the line. So here we can say angle 1 is corresponding angle with angle 5. So let's write it. Angle 1 and angle 5 both are a pair of corresponding angle. Similarly, angle 2 and angle 6 both are pair of corresponding angle. Similarly, we can also say the downside angle, that means angle 4 is corresponding angle with angle 8 and angle 3 and 7 are pair of corresponding angle. Now let's see alternate interior angle. So the way we have collected alternate exterior angle, similarly we will collect alternate interior angle. Interior means inside part, alternate means one on the left of the transversal, one on the right of transversal. So here angle 4 and angle 6 are a pair of alternate interior angle. So angle 4 and angle 6. Similarly, angle 3 and angle 5. Now one thing you must know from here is when line M is parallel to line N, then we can say the alternate exterior angles are equals to each other. Similarly, we will say the sum of interior angle on the same side will be 180 degree. And for the other angles which we have collected so far, we will say that corresponding angle will be equals to each other when two lines are parallel to each other and getting cutted by a transversal. Alright, similarly alternate interior angle will also be equals to each other. So let's write it. So here when M parallel to N, then and only then we can say angle 1 is equals to angle 7 and angle 2 is equals to angle 8. And when M is not parallel to N, then we will say angle 1 will not be equals to angle 7 and angle 2 will not be equals to angle 8. Both are alternate exterior angle, but both will not be equals to each other. Alright. Similarly, angles on the same side, when both are parallel, M and N are parallel, the sum of both the angle will be 180 degree. Here also angle 4 plus angle 5 will be 180 degree. And when it's not parallel, then angle 3 plus angle 6, the sum will not be 180 degree. Here also angle 4 plus angle 5 will not be 180 degree. Alright, let's see the other angles also. So here corresponding angle will be equal to each other if and only if M is parallel to N. So angle 1 will be equals to angle 5, angle 2 is equals to angle 6, angle 4 is equals to angle 8 and angle 3 is equals to angle 7. And if they are not parallel, then angle 1 will not be equals to angle 5, angle 2 will not be equals to angle 6, angle 4 will not be equals to angle 8 and angle 3 will not be equals to angle 7. Still, the name of the angles are corresponding angle, but the equality depends upon the parallel condition. The last one, when M is parallel with N, then angle 4 and angle 6 are equals to each other. Similarly, angle 3 and angle 5 are equals to each other. And when they are not parallel, then angle 4 will not be equals to angle 6 and angle 3 will not be equals to angle 5. Now let's see one theorem related to parallel line, which says lines which are parallel to the same line are parallel to each other. Let's understand it in detail. So let's say we are having one line L, one line M, and one more line, that is line N. Now here, if L is parallel to M and M is parallel to N, then we can say L and N are also parallel with each other, or we can also say that L is parallel to M and M is parallel to N. All three lines are parallel with each other. Alright, now let's solve one question related to it. So here the question says, in the given figure, if PQ is parallel to ST, we can see in the figure, angle PQR is already given as 110 degree and angle RST is also given as 130 degree. Then find QRS. So here it's given that PQ is parallel to ST. And now let's draw one more line, that is MN parallel to ST. So we have drawn a line MN which is parallel to ST. Now here, if MN is parallel to ST, then we can also say that RN is parallel to ST, right? And SR works as a transversal. Can you see it? So can we say the sum of interior angle? That means, let's say this is angle X. So angle X plus angle S or angle RST is equals to 180 degree. I'm talking about the sum of this angle and this angle is equals to 180 degree. Why? Because it's interior angle on the same side, right? Let's write it. So from here we got X is equals to 50 degree. Now similarly, let's say the another angle on the other side of angle R, it's Y. So similarly, since ST is parallel to MN and PQ and ST are parallel with each other. So can we say all these three lines, that means ST, PQ and MN, are parallel with each other? So since we know ST is parallel with PQ and it's parallel with MN, all are parallel with each other just by the previous theorem. So we can say angle Y plus 110 degree is equals to 180 degree, right? From here we will get the value of angle Y, that means 70 degree. So we got the value of Y as 70 degree and we got the value of X as 50 degree. Now we have to find angle QRS. Alright. So angle QRS means this green angle, this one. Okay. So can we say angle Y plus angle QRS plus angle X is equals to 180 degree? Why? Because it's a linear pair. So we can say 70 degree plus angle QRS plus 50 degree is equals to 180 degree. Here we can write all are linear pair of angles. So from here we will get angle QRS is equals to 60 degree. And hence we got angle QRS. Now here we are having a theorem related to triangle. You must know this theorem. You have learned this in previous class. So the theorem says the sum of angle of a triangle is 180 degree. That means the sum of interior angle of a triangle must be 180 degree. That's called angle sum property of a triangle. Let's see it in figure. So here if we are having a triangle ABC, then it says the sum of interior angle, that means angle 1. Here let's say it's angle 2 and here let's say it's angle 3. The sum of interior angle, that means angle 1 plus angle 2 plus angle 3 is equals to 180 degree. Here we will prove this theorem. So let's prove it. Now let's prove it with the help of concept of parallel line. So let's draw a parallel line, a line parallel to BC. All right. Let's say this is line ST. Now here let's write it. We have drawn a line ST parallel to BC. Now here let's say this angle is X and this angle is Y. Since ST is parallel to BC, can we say AB works as a transversal over here? Yes, we can say AB is a transversal and hence angle X will be equals to angle 2. Why? Because it's alternate interior angle. Hence we can say that angle 2 will be equals to X. Here we can write alternate interior angle. Similarly, once again, let's see ST is parallel to BC. So we can also say that AC works as a transversal line. Can you see AC? Yeah. So we can also say that angle 3 will be equals to angle Y because it's alternate interior angle. So 2 is same as X and 3 is same as Y. Now let's focus on a straight line ST. So can we say angle X plus angle 1 plus angle Y is equals to 180 degree because it's a linear pair. All are sitting on a same straight line. Yes, we can say. Now here X is same as angle 2 and Y is same as angle 3. So instead of X and Y, let's write angle 2 and angle 3. So from here we can write angle 2 plus angle 1 plus angle 3 is equals to 180 degree, and that's what we wanted to prove, right? The sum of interior angle, that means angle 1 plus angle 2 plus angle 3 is equals to 180 degree. Please note that sequence doesn't matter since all are in addition with each other. So hence we have proved the theorem. Now let's see one more theorem. So here the next theorem says if the side of triangle is produced, then the exterior angle so formed is equals to the sum of two interior opposite angle. Let's understand it with the help of figure. So if we are having a triangle like this, let's say it's a triangle ABC. So if we will produce any of the side, that means if we will extend the side, then the exterior angle so formed will be equals to the sum of opposite interior angle. That means here if we are talking about this angle x, then this x will be equals to the sum of angle 1 and angle 2. Here x is equals to angle 1 plus angle 2. If we will produce the another side, that means let's take the same triangle. And if we will produce from the left side, that means from B, then the exterior angle, that means angle B, let's say its angle Y, will be equals to the sum of angle 1 and angle 3. Here Y is equals to angle 1 plus angle 3. Similarly, we can also produce through A. So here we know sum of interior angle. So if this is angle 3, then we can say angle 1 plus angle 2 plus angle 3 is equals to 180 degree by angle sum property. Let's say it's equation 1, and we can also say that sum of angle 3 and angle x will be 180 degree because it's a linear pair. Can you see? Let's say it's equation 2. Now from equation 2, can we write angle 3 is equals to 180 degree minus x? Let's substitute this angle 3 value in equation 1. So we are having angle 1 plus angle 2 plus angle 3. At the place of angle 3, I am going to substitute 180 minus x. I am substituting angle 3 value over here. Okay, is equals to 180 degree. Let's simplify it. So we will get angle 1 plus angle 2 minus x is equals to 0. And we can also write it as angle 1 plus angle 2 is equals to x. And that's what we wanted to prove, right? When we will extend one of the side, then exterior angle so formed will be equals to the sum of other two or opposite to interior angle. So hence we are done with the proof. Now let's solve one question by using the previous theorems. So here our question says, in the given figure, we can see the figure over here. The side QR, can you see the side QR of triangle PQR is produced to a point S. So the side QR is extended if the bisector of angle PQR and PRS, please note it says bisector. That means both the angles are getting divided in equal part. Bisector of angle PQR and angle PRS meet at point T. As we can see in the figure, then we have to prove that angle QTR is equals to half of the angle QPR. So this is QTR, right? And this is QPR. Can you see the green color angles? Yes. Okay, so let's do it. Here at first, let's focus on triangle QTR. Let me draw it separately. So here, can we say angle TRS is equals to the sum of opposite interior angle. So the sum of this angle, angle T and angle Q. Let's write it. So we got from here that angle TRS is equals to the sum of angle TQR plus angle QTR. All right. And here we have to write it in bracket the previous theorem that whenever we are producing one of the side, then exterior angle is equals to the sum of two opposite interior angle. Let's say this is equation 1. Now let's focus on triangle PQR. Let me draw it separately. Can you see triangle PQR? Yes. So here also exterior angle, that means angle R, will be equals to the sum of two interior angle, that means angle Q and angle P. Let's write it. So angle PRS will be equals to angle PQR plus angle QPR. Let's say this is equation 2. Now we know that here QT or TQ acts as a bisector of angle PQR. So we know that angle PQT is equals to angle TQR, and also angle PRS is getting bisected. So we can also write angle PRT is equals to angle TRS, right? Now at the place of angle PRS in equation number 2, let's focus on PRS. This is the angle PRS, right? At the place of PRS, that is this complete angle, can we write it's equals to 2 times this angle, that means TRS, because angle TRS is same as angle TRP, right? This one and this one is same. So if this is X, this is also X, and completely it's twice X, right? So can we write it as 2 times angle TRS, all right? Now at the place of PQR, again it is the angle PQR is getting bisected. See carefully. So at the place of PQR, can we write 2 times angle TQR? So at the place of this, we can write twice of angle TQR plus angle QPR. Let's keep it as it is. Let's say this is equation number 3. Now from equation number 3, we can write angle QPR is equals to twice of angle TRS minus twice of angle TQR. Let's say this is equation number 4. We have not done anything with equation 3. We have just changed the side. We have shifted this part over here. Now from equation number 1, if we will substitute angle TRS in equation number 4, then let's see what we will get. So angle QPR is equals to twice of angle TRS in equation number 1 is equals to angle TQR plus QTR. Let's write it. It's angle TQR plus angle QTR. All right, minus twice of angle TQR. Now let's apply the distributive property and open the bracket. So angle QPR is equals to twice of angle TQR plus twice of angle QTR minus twice of angle TQR. Now can you see we are getting the like term? Twice of angle TQR, the first term on the right hand side and the last term on the right hand side are cancelling each other. So let's cancel them. So we got, and from here we can write angle QPR is equals to twice of angle QTR. And if we will shift 2, which is sitting on the right hand side, in multiplication with angle QTR on the left hand side, we will get 1 by 2 QPR is equals to angle QTR, right? And that's what we have to prove it. So hence we are done with our proof. Got it? I hope you have understood the whole concept on lines and angles. Stay tuned for the next video. Thank you.